Hi. So this is our second topic that we're going to cover in this week 3. Um, so first note that we are changing our textbook for this part. We are going to Apex Calculus. The link is also in the Canvas home page. So if you go there, actually let me show it to you. So I think you can see the screen now. Um, so this is the home page. Let me go to student view. Yep. So you can see the page right now. And this is the textbook we'll be using, Apex Calculus. And we're going to chapter 10.1, conic section. Makes sense? Also, let me say a few words about the active calculus textbook because many of you have raised some questions and concerns about it. So if you look at the active calculus textbook, it has 3 components. Number 1, in-text examples. For example, um, let's see. Okay, let's go to a different chapter maybe. Chapter 6.2 because 6.4 has no exercise example. Yep, look at this. So this is chapter 6.2. This is a so-called example. Okay. And you can click on the solution to see the solution, or you can do it on your own. So this is one component. The other component is preview activity and, so for example, this one, and activities. So this one. So I do not mean exercise when I say activity. So by activity, I mean this in-text problems. And then there is exercise, which you can find if you scroll down to the bottom. There is separate dedicated section for exercise. So these are what I shall be calling exercise of active calculus textbook. So when I say look at the activities of the textbook, I do not mean exercise. Okay. I will specifically tell you. Okay. So I guess you can see my own notes now. Okay. So we're going to talk about conic section. Now, why do we call conic sections conic sections? So as you can see, if you take such a 3D object like this, and if you cut it, so for example, in this picture, I'm cutting it in this way. The section of the cut that you will get is called a conic section. For example, if I cut it in this manner, I will get this object as you can see up here. These are typical parabola. If I cut little above like this, I will get ellipse. If I cut horizontally, I'll get circle, and if I cut entirely vertically, then I'll get hyperbolas. So my task for this video is to describe parabola, ellipse, and hyperbola to its details. Just keep in mind that equation of a conic section. So as you can see, these conic sections will either look like this, maybe something like this, or maybe something like this. I got it correctly. Or it will be something like this. So this is parabola, ellipse. Keep in mind that circles are also ellipses, and this is hyperbola. Lines and two lines like cross lines, these are also conic sections. So look at the textbook for that. But the most important conic sections are these three. No matter what, every conic section has this equation. Like the equation of this conic section has a typical format. Ax squared plus bxy plus cy squared plus dx plus ey plus f equals to 0 for certain choice of a, b, c. So for different choices of ABC and some different properties of ABC, the equation will give me either a ellipse or a parabola or a hyperbola or two lines or whatever. But no matter what, the equation would always look something like this. Okay. And you can see like this is a 2D graph. So they have the standard 2D equations. Anyway, let's start our discussion with parabola. So I'm going to just talk about parabola, ellipse, and hyperbola. Okay, so for parabola, let me just copy the definition and the key properties of the parabola. Then I will describe what these are. Okay, so what is a parabola? So look at this diagram first very carefully. So first, I'm choosing a very special point and a very special line. So this point is called focus and this line is called directrix. Now consider, hear me very carefully, consider all those points which are equidistant from the focus and from the directrix. Example, look at this point. The distance from the focus is called d and the distance from the directrix is also d. So this point is equidistant from the focus and the directrix. If you take this point, then you can also note that this also has same distance from focus as from the directrix. So if you consider all such points and you look at the collection of all these points that have the distance equal from focus and directrix, they will create this figure called parabola. Sorry. Make sense? So the most important two properties of this parabola are focus and directrix. However, there is also a very special point. Once you find out the parabola itself, meaning the vertex. So what is vertex? So vertex is the very point. So, okay, by the way, I told you that focus is a very special point, right? Because you need it to get started with the parabola, right? So focus and directrix are there. Now consider a perpendicular line to directrix that passes through the focus. Okay. This is called axis of symmetry. Makes sense? So axis of symmetry is the line that passes through focus and that is perpendicular to the directrix. And naturally, this perpendicular line will cut the parabola. And this point of intersection of the axis of symmetry and the parabola is what we call vertex. Now, vertex typically signifies the highest or the lowest point of the parabola, meaning, I mean, if you look at the parabola from the angle of, for example, look at this. So this is so-called the vertex, right? Most probably the focus is somewhere here, and probably some line here is the directrix, or maybe x-axis, who knows. I'm just creating a random parabola. Make sense? Or a parabola can be this, right? Or a parabola can be this, right? With some vertex, some directrix, some focus. Okay. So these are all parabolas. Keep this in mind. Okay. So let me label different type of parabolas. So do not keep this idea in your mind that parabolas are always straight vertical or straight horizontal or something like that. Like, meaning this can be also. So let me draw a picture. My bad. Yeah. So this is a perfectly horizontal parabola. Okay. So you can have a lot of types of parabolas. Okay. Any question? I mean, all right. So now let's do some math. So for this section, we will always stick to the case when the directrix is either horizontal to x-axis or horizontal to y-axis. So we are not going to consider equation of this hyperbola. So our hyperbolas will be either this or this, like in perfectly horizontal or perfectly vertical. Okay, so let's look at that. So equation of parabola. And the equation is from the textbook. Let me just copy it. As you can see, the first equation, this is for a vertical parabola, meaning that the directrix is parallel to the x-axis. Okay. Or much better way of saying it is that the axis of symmetry is vertical. So meaning that this is the axis of symmetry. And this is the situation the next equation is for the like that axis of symmetry being vertical. Okay, so this is the axis. So horizontal symmetry. Okay. So let's be more precise. So in the first equation, maybe the this is the directrix. So the equation of directrix is y equals to k minus p. Okay. The focus, the vertex is at h comma k. So let me first draw the. So this is the vertex. This is the focus, and this is the vertex, and you need a. This is the focus. So the focus has coordinate h comma k plus p. The vertex has coordinate h comma k, and the directrix is y equals to k minus p. So in that case, the equation would be this. Make sense? So to be honest, all you need to so there, as you can see, like there are like 4 properties, right? So 4 key ingredient, which is focus, vertex, equation of directrix, and equation of axis of symmetry. If you have either of these two, you can write down the equation, and the equation would be, say, y equals to 1 over 4p x minus h whole squared plus k, right? And you can go around. Suppose I give you an equation of parabola which looks like this. Then you can, from there, you can write down the points, meaning focus and vertex, the line of directrix line, the line of symmetry, and everything. Okay. So if I give you just either of these two, you're good. So either of these, like either two of these 4 components, you can write down the equation, and vice versa. If I give you the equation, so a very standard question in this parabola kind of or ellipse kind of problems is that I will give you an equation which might not look like this, which might look like, say, y equals to x square plus 2x plus h square plus k. And then I ask you that, okay, what is the maybe equation? Then you have to algebraically manipulate the equation to get something like this, and from there conclude. Okay. So let's see 2 example. So find equation of parabola with um, focus at 1, 2, and the directrix is y equals to 3. So remember, the focus had coordinate hk plus p, and the directrix had coordinate y equals to k minus p, right? Right? And in that situation, the equation is simply this, right? So now solve it. So h is 1, k plus p is 2, and k minus p is 3, right? So you can solve very easily. So 2k is 5, meaning k is 5 over 2, and meaning that 2p is -1, p is -half, right? So you know all the values, so now you know h, now you know k, and also p, right? So now write on the equation. So the equation is y equals to 1 over 4 -half x minus h whole square plus 5 over 2. So simplify, -half x minus 1 whole square plus 5 over 2, and that's your y. That's it. So notice that first of all, I noticed that the directrix is uh, parallel to x-axis, right? So that's how I could use this. Had the directrix been something like x equals to 5, then I had to use the other formula, meaning this one. Okay. Next, the other example I was talking about. So find focus and directrix of the parabola x equals to 1 over 8 y square minus y plus 1. So in C, the equation here is x equals to 1 over 8 y squared minus y plus 1, right? So the quadratic expression is in y, right? That means the directrix is parallel to y-axis, meaning we are now dealing with a parabola that looks like this. See, in this equation, if you expand, it is 1 over 4p y squared minus 2ky plus k squared plus h, right? So this guy is a quadratic in y. So whenever you see a quadratic expression in y, know that the parabola is horizontal. On the other way, if the quadratic equation is in x, the parabola is vertical. So here, the quadratic expression is in y. So the parabola is horizontal. So what you expect is an equation that looks like 1 over 4p y minus k squared plus p, right? Plus h, sorry, plus h, right? So somehow you have to make the right hand side look like this. So make look like 1 over 4p y minus k whole square plus h, right? And how do you do it? Very simple. So on one hand, you have this expression, and on the other hand, you have this expression, right? So first of all, simplify this. What you get, so what you get when you simplify is 1 over 4p y squared minus 2ky plus k squared plus h right? Now gather the constant, gather the y term, and what should you do now? Just compare, right? So this is plus negative y. My bad, my bad. Yeah. So compare. So if I compare the y squared terms, what do I get? By comparing coefficients of y squared, y, and the constant term, we get, what do you get? You get that 1 over 4p is 1 over 8, meaning p is 2. Now compare the y terms. So negative 1 is negative k over 2p, but p is 2. That means negative k over 4, meaning k is 4. And finally, if I compare the constants, what do I get? 1 is equal to k square over 4p plus h. But you already know k and 4, right? From the previous calculation. This is 4 squared over 4 times 2 plus h. This is 2 plus h. So h is 1, right? So comparing y squared, comparing y, and this is comparing constant. We're not done yet. Recall that the directrix had the following equation. So the directrix equation of directrix is what? X equals to h minus p. Copy the value of h and p. So the equation of directrix is x equals to minus 1. Right? And focus is h plus p comma k, which is 1 plus 2 comma 4, which is 3 comma 4. That's it. So you should expect some problem like this. Okay. Now let's talk about ellipse. So in case of parabola, you saw that we need a point calling the focus and a line, right? Which we call the directrix. In case of ellipse, you need 2 points. Uh, each of them we call focus or like foci. Okay, so for example, in this case, you can see that there are 2 points, each being a focus. And what does it happen? Well, so consider all the points such that if you sum up the distance of that point from the foci, the sum is constant. So if you take any other point on the ellipse, sum of these two lines is equal to sum of these two lines, lengthwise. Okay. Or a much better way of describing is that take 2 points, attach a string of any length, and then pull a pencil and like keep rotating the pencil like try to move the pencil while the string is in its uh in a like in a straight way, if that makes any sense. So yeah, like just read it. Like hold the pencil tight against this that string and then keep moving. If you do that, you will get an ellipse. Anyway, um, a quick remark. If these two focus, if these two foci coincide, what you get is a circle. Okay. So circles are kind of ellipses. Okay. Now let's talk about the fundamental components of an ellipse. For example, parabola had like 4 fundamental components: focus, vertex, directrix, and line of symmetry. Similarly, ellipse also has 4 fundamental components. One of them is certainly focus. So it has 2 focuses or 2 foci. Then there are 2 axes of symmetry here. This is called a minor axis. This is called a major axis. Okay. And the points at which the major axis cuts the ellipse are called vertices. So there are 2 vertices. In other words, what is major axis? Major axis is the line passing through the foci. And what is minor axis? Well, it's a line that is perpendicular to the major axis and that also divides the line segment between the foci. So you have major axis, you have foci. Look at the midpoint of this line segment between 2 foci and draw a perpendicular line. That's it. Make sense? And again, yeah, from this information meaning from the length here or the length here or the length here, you can be able to find out the equation of the ellipse. So let me just try to show it to you. By the way, so let me make some few more pointing out here. So this B up here is called length okay, actually let me not do this. So length of major axis length of minor axis is 2b. Okay. And I don't know whether there is a name for this. Yeah. So distance between the foci, simply 2c. So that's why this ABC diagonal like number signify. Anyway, let me also write down the equation, which is again going to be something copy paste. So as you can see that ellipse can also be either vertical or horizontal, right? So for example, in this case, this first equation is about an ellipse that is horizontal. Okay. And the second equation is when, so I mean, a ellipse being horizontal meaning the major axis is horizontal. And what about this guy? This is the major axis being vertical. I'm sorry. All right. Let's start doing a problem. So maybe yeah. So let's start from the equation and then try to get the point. So sorry. So the equation is the following: 4x squared plus 9y squared minus 8x minus 36y equals to -4. Find all the important points. So first of all, we have to make it look like something like this. Okay. And the first question is, how do you see whether this ellipse is vertical or horizontal? So you will see all of that once you write down the equation. So meaning, first try to complete square. How do you do it? Notice that the equation is 4x squared. I'm rearranging a little bit. Plus 9y squared minus 36y equals to -4. Now, this guy can be written as 2x whole squared minus 2 times 2x times 2, right? Plus 3y whole squared minus 2 times 3y, 6 times 6, right? Minus equals to. There's a reason I'm writing in a way. So I'm going to use the fact that a squared minus 2ab plus b squared is equal to a minus b whole square. So that is why I broke 4x squared minus 8x and all these things in such a manner. So see, all this expression is missing is plus 2 squared and plus 6 squared. If I have these two numbers, I can complete the square. But then I don't have this. So I have to separately do a -2 squared, my bad, and -6 squared. Okay. And this will be equal to -4. So rearrange everything. So 2x minus 2 whole squared plus 3y minus 6 whole squared minus 4 minus 36 equals to -4. Meaning 2x minus 2 whole squared, 3y minus 6 whole squared is equal to 36, right? This should make sense. Now compare it with your equation. In your equation, you always have a 1 on the right hand side. So this 36 has to be 1. So divide the entire equation by 36. So you get 2x minus 2 whole squared by 36 plus 3y minus 6 whole squared over 36 equals to 1. Remember the equation. So that means x minus 1 whole squared over, okay, I'm pulling out the 2 and I'm pulling out a 3. So what I get is 9 plus 4 equals to 1. So the equation is actually this. Why did I do all this? So that the equation now looks like an equation of an ellipse. Now I have to figure out which one is major axis and which one is minor axis, right? Okay. As you know, that the major axis is always just a moment. Okay. So now let's go back to the equation. So remember that the center was of the coordinate h comma k, right? And if the center is h comma k, the equation is this, right? So in this equation, our center h comma k, which is 1 comma 2, right? Because compare the equation. Okay. Now what is a? A, so this is a square is 9. I mean, compare it with the equation here, x minus h whole squared over a squared plus y minus k whole squared over b squared is equal to 1. So a squared is 9, meaning a is 3, and b squared is 4, meaning b is 2, right? Okay. Now you can see that the length of major axis is 6. And the length of minor axis is 4. Meaning the major axis is larger, and hence this is the horizontal ellipse. And what is the distance between the foci? This is just 5. That's it. Okay. Now, sometimes you will be asked to like find out the line. I'm not sure like whether this will be the case, but sometimes one can ask that what is the equation of the line going through, like the equation of the major axis, equation of the minor axis, and things like that. But you don't worry about it. So maybe if I try to draw a picture, no, make it straight. Damn. Let's see if I can do something. Oh, okay, this is not too bad. So minor, major. Also, this is the center, which is 1, 2, right? This length is B, which is 2. This length is 3, right? And also remember that the focus, I mean, this point is the midpoint of the foci, and the distance between the foci is square root 5, right? So this length, just a moment, yeah. So this length is C, which is square root 5, right? So this is a point 1, 2. The major axis is horizontal to the x-axis, meaning the first focus, you just shift the x-axis, right? So that means the coordinate of this focus is 1 plus square root 1 plus square root 5, 2, and this is 1 minus square root 2, right? Because these two are, both of this line segment has length square root 5, the midpoint. So you can actually shift the x-axis by the length of the distance C to get the focus. So the foci, 1 minus square root 2 and 1 plus square root 5, 2. That's it. Also, remember that there is something called eccentricity. So what is eccentricity? Eccentricity is C over A. So C is square root 5, A is 3. So this is the eccentricity. Let me highlight this. So that you don't miss. So that's all about ellipses. And finally, we have hyperbola. So hyperbolas are like very different from ellipse in picture, but in equation they are very similar. So let me just copy paste this guy. So I'm not going to do an example for hyperbola because it is exactly same as ellipse. Here you go. So hyperbola would look like this. Let me just walk through the elements of hyperbola. So hyperbola looks like this. It also has two foci, this and this. And again, you are looking at all those points where the distance, okay, in the case of ellipse, you took some of the distance from the foci. In case of hyperbola, you will take difference of the distance from foci and take the positive part of it, meaning that if it is here, so consider the distance of this line and distance of this line and take the difference. When you are on this side, take this distance and take this distance, subtract them. The point is, for a hyperbola, all of this difference of the distance would be same. Okay. You also have something like major axis and minor axis. Actually, we call it transverse axis and conjugate axis. So this is the transverse axis, and this is the conjugate axis, and this is called the center, whose coordinate would be h comma k. So let me just write it down. Okay. And we also have vertices. Vertices are those points where the major axis or the transverse axis cuts the hyperbola. So this one and this one. And let me just see for a moment. Okay. And there are two distances you have to consider. So this distance A that you are looking at, this is the distance of the center from the vertex. And this is what you call A. And there is this other distance, which is distance of the focus from the center, and you call it C. What? Yes. Okay. And we have this relation C squared equals to A squared plus B squared. Okay. So if the transverse axis is horizontal, then the equation is this. If transverse axis is perpendicular, the equation is this. Sounds good? And what are this A and B? You can see A is the distance of the vertex from the center. Then, okay, if you know B, then A square plus B square will give you the distance from the focus, distance of the center from the focus. So, B is like, B doesn't represent any length here, most probably. I guess not. Yeah, B doesn't really represent any length in this situation. Or maybe it does. Wait. mm, Let me think for a moment. Yeah, B does have a meaning. Um, the meaning of B comes from, okay, let me just share the screen so you can see it on here. Okay, here we go. So, okay, look at this hyperbola first. So this is the center, as you can see, center. You can draw these two lines. What are these two lines? These are the lines along which the hyperbola asymptotically extends. Okay. Anyway, so yeah, if you try to draw a tangential line to the vertex at this hyperbola, this will cut this two, like, I guess, what do you call it? This asymptotic lines at this 2 point, and the length of this line is actually 2b. So I'm thinking, should I spend too much time about this? No, it's fine. Okay. Yeah, I mean, just remember this equation of vertical and horizontal transverse line. So if you know the equation, if you know the equation of the of the hyperbola, then the transverse line will have this equation, and the vertical transverse line will have this equation. Don't worry too much about this. just make sure that you can actually write down a hyperbola. For example, okay. For example, look at this question. I give you this following equation, 9x squared minus y squared plus 2y equals to 20. Find out the equation of the hyperbola. So again, you kind of complete the squares. So how do you do it? So see, this is 3x whole squared minus y squared minus 2y. I'm forcibly bringing a 1, but then at the same time, I have to balance everything. So 3x whole squared minus y minus 1 whole squared equals to 19, right? I'm sorry, and this is 10, my bad. Then this is just x squared minus y minus 1 whole squared over 3 squared, right? And compare this with x minus h whole squared over s squared minus y minus k whole squared over b squared equals to 1, right? So you can see that this is actually x minus 0 whole squared over 1 squared, right? That's it. So you know the coordinate h comma k, you know a, you know b, you know everything. Any question? I mean, it's kind of pointless to ask question. So that's it. I will soon post an assignment. I will give you problems that I have just covered over here in the lecture note. So don't worry too much about it. Okay. That would be all for this week. Thank you.